right, let's do some more observations here. Let's say 10 to the 6 divided by 10 to the 2 instead of multiplication. We've been working with multiplication. So what happens, do you think, if you do division? I'm going to let you explore that on your own for a little bit. Just remember, whenever you encounter something that you have not seen before, what are you going to do? You're going to write that in the expanded form using the notation 6 copies of 10 divided by 2 copies of 10. So you remember from division, you can simply have 10 goes into this 10 giving you 1, 10 goes into this 10 1 times, multiply this together. What is left now? You can see that you have 1 on the bottom and you have 4 copies of 10 left on the top. Or we had 6 copies on the numerator, 2 copies in the denominator, and so the difference is you have 4 copies left in the numerator. And so what we have is 10 to the 6 over 10 to the second. Base is 10. You subtract the exponents. We should have expected it because we know how addition and subtraction are always working hand in hand. Multiplication, division are reverse operations of each other. Addition and subtraction are reverse operations of each other. When you multiply same base to a power with same base to a power, you add the exponents. So addition, subtraction is the reverse operation of addition, and division is the reverse operation of multiplication. And so it makes sense that we would have to subtract the exponents. All right, so let's see if you can do this example on your own. I'll do the initial setup for you, and you tell us what the answer is going to be. So pause the video here to finish the problem. Yep, very good. X to the 5, because you ended up with 5 copies of X that are left up here, because you have 8 on top, 3 on the bottom, and so you end up with a 1 on the bottom. So this X goes into this X and gives you a 1. This X into this X gives you a 1. This X into this X gives you a 1. And so we have X to power 8 or X to the third. Base is the X. And the exponents, numerator exponent is here, denominator exponent is here, and you're subtracting the two. Pause this video if you have to until you completely assimilate all of this. So division gives you subtraction of exponents when you have the same base. All right, let's do, whoops, sorry about that. Let's do some more examples here. In order to do this example, remember what we did before. Simplify the insides first. So we did that, and you got 10 to the 4. Now you have 3 copies of 10 to the 4. So every time you develop a new observation, you want to see how it fits in with the already developed observations. And this is one of the reasons why mathematics is so hard, because if you forget what happened in the previous lecture, you can't really build something on top of it, right? So do make sure that you have this really well, because it's going to help you tremendously in the later lectures. So what about this? What do you think we should do here? I don't want to write with 14 fives. I can't even speak it properly. But yes, 14 fives multiplied together, divide by 3 fives multiplied together. We're going to end up with, yep, 14 minus 3, or 5 to the power 11. You're going to end up with 11 copies of 5. How about this next one? What do you think we should do? Pause the video, think about it, and then write the answer. Base is the same, 2a minus b. Yes, very good. Yeah, you're going to do 5 minus 2. That's right. So it's going to be 2a minus b to the power 5 minus 2, or to the power 3. 3 copies you're going to end up with, because there's 5 on top divided by 5. Remember, this whole thing is your base. All right? How about here? What are you going to do here? That's correct. Yeah, you should take the inside here. It's d to the 13 over d to the third. So you have inside here will become d to the power 10. And then square 2 copies of it. So what do you do with the powers here? 2 copies of d to the 10 will give you 20 copies of d. Why 20? Because d to the 10, another d to the 10, 20 copies of d. What about this? All right, base is negative b, and then you subtract the powers. So this is exactly how your next video set questions is going to be. So get your paper, pencil ready, and then we will start your next video log question set. All right, you ready for your video log questions then? Remember, whatever problem you see in front of you, you're going to write that as one base and one exponent. You ready? Let's see what you can do. By the way, we have these problems appearing all over the screen is to have you active and not a passive learner. You want, no matter where the problem appears and how it appears, what the base is, as long as you know the meaning, you should be able to do it. So what you get here? I guess I'll do the first one for you. Ready? So we have 10 to the 2 to the 10, 2 to the 4. So this division means you're going to end up at 2 to the 6 because 10 2's on top, 4 2's on the bottom, subtract, because you can cancel 4 2's, right? That's why it's subtraction. These 4 2's will cancel out with these 4 2's and you'll be left with 6 2's. 3 copies of 2 to the 6 will give you 18 copies of 2. So you have 3 copies of 6 2's. Multiplied together will give you 18 2's. All right, you're on your own for the next set of problems. Ready? Go. Base is 5, remember here. At any point, pause the video if it's going too fast and you haven't finished writing. Make sure you write the problem down. Make sure you identify base and exponents and finish it off. All right. So now we can summarize our observations as following. For all counting numbers n and m, and for all non-zero numbers a, we need non-zero because we have a division here. You can't have division by 0, so that's why we need to say non-zero real numbers a. Or non-zero mathematical objects would work too. As long as your denominator is non-zero, same base, power of n on numerator, power of m on denominator, m of these would cancel out with n of these and you'll end up with that. Let's just quickly look at an application of what we just looked at. 2 to the third over 2 to the third. If you use our rule that we just designed, you'll end up with 2 to the 0. What's 2 to the 0? We haven't defined 2 to the 0 yet. But take a look. We know that this is the same as 8 over 8. And we know what that is. That's a 1. And so if you take any number to the same exponent and the same base to the same exponent, you'll end up with 1 always, which is the same as base to 0 power. So we're going to define number to the 0 power as 1. Keep that in mind. And so it's really, we're saying to be consistent with our observations, this is what we need a to the 0 to be.